C4, Chapter 9, Scalar Products. What we're going to start off with isn't necessarily scalar products to start with, it's like preparatory work. I'm going to ask a few questions to start with. The first one, how far is the coordinate point 3 minus 8 from the origin? So it's sort of GCSE work really. How would I find out how far 3 minus 8 was from the origin? 3 squared plus the negative 8 all squared, added together, square rooted. Yeah, it's an application of Pythagoras' theorem. Because from the origin, you went 3 right and 8 down. So it's a right angled triangle. If you do that, you get root 73. Okay. So next question will be, how far, and this time it's going to be, is it between 3 minus 8 and 7, 2? How far is it between those 2 points? Again, quick recaps. We're not going to the origin anymore. Will there be a sum like this, and if so, what will the sum be?
7 minus 3.
7 minus 3.
And then plus 2 minus 8.
Minus 8.
So 2 plus 8. And then add them together, square them, and square root that.
Yeah, you can square them first, okay? So square them, add them together, and square root. Okay? Usually, if you had started with the point over here, that's the x one, isn't it, there, and then the y one. Yeah, that's fine. Leave it like that, that's fine. 116, that one, yes. Okay. So, generally, how far is it between x1, y1 and x2, y2? In other words, we're looking for a red box rule that we had beginning of year 12, which Sam Shuff is about to tell us.
x2 minus x1 all squared plus y2 minus y1 all squared square root.
That's correct. Exactly right. Yeah. Okay. Distance between 2 points, a general form. So, we'll remember that. We'll come back to that in a minute or two. Going to look at some 3D stuff next. 3D stuff in vectors generally isn't any harder than 2D stuff, which is quite nice really. It's just got an extra row of numbers in it. So, going to have first of all a position vector. Position vectors are always measured from the origin. Position vectors always measured from the origin. Position vector is going to be OA. In other words, how you get from O, the origin, to A. Also could be written down as A with that little wavy line underneath it, and it's going to be 2 minus 5, 6. That's my position vector OA. It's another way of saying basically the coordinate 2 minus 5, 6. What I want to know first of all then is what is the length of the vector OA, of the position vector OA. So it's very much like what we did earlier on. It's three-dimensional though, it's not two-dimensional. The length of the vector O to A, basically it's saying what is the distance from O to A. We had the very first question this afternoon was what's the distance from somewhere to the origin. What's it going to be here? Distance, sorry, the length of that vector. Someone's going to start off? Oscar? What do you think it will be? And I think you'll be right.
The square root of 2 squared plus minus 5 squared plus 6 squared.
Square root of that. That's exactly right. Yes. Okay. That is how you find it. So that's going to be 4, 25 and 36. That's going to be 65. It's still square root. Don't be tempted to think it's cube root because it's 3 dimensions. It's still square root, even though it's 3 dimensions. And when you find the length of a vector is called its modulus. So that's a new use of the word. Modulus is the length of a vector. And the notation that they sometimes might use is vector OA inside two vertical lines, just like normally actually for modulus, or it could be down A is the thing under it there, okay? So that length of a vector is called its modulus. We use normal mod symbols, and it just means basically if it's a position vector, how far is it from the origin.